Hi everybody. We missed two of the problems towards the end of 9.5 that I was going to go ahead and cover real quick. So I'm going to go ahead and jump into it. So it's on the last page. So you'll see that one of them says find the equation of the tangent line of f of x equals 3x cubed minus 2x squared plus 5 at x equals 2. So to begin to understand what this problem is even asking, I think I'm going to start with a graph. So basically I type this in. I put f of x equals 3x cubed minus 2x squared plus 5 into y equals. Then I went to the table, and from the table I will graph it. So let me put the graph right here actually. So if I look at the numbers, maybe like -3, -2, and then all the way to +3. -2 goes to 20, -27, -3 goes to -94. So we could probably go by tens. So 10, 20, -30. Right, over here we can just go by ones. -2, -3, 1, 2, 3. So it's -10, -20, -30. This will be +10, +20, +30. Okay, and I'm not going to graph all of them. I'll just graph a few. But so -2, -27. So notice I chose not to do -3 because it's kind of far down there at -94. I'm not really going to need it. So -1, 0, 0, 5, 1, 6, and 2, 21. Then I'll go ahead and hit graph, 368 is kind of out there. Okay, so I just know it's going to go up. Okay, but if you think about cubics, you should kind of have an idea. Cubics look something like that. Okay, so I can kind of see that trend. That's really all I need for what we're doing right now. Okay, so this is kind of the idea of what the graph will look like. Now back to the question. The question's asking at 2. Find the equation of the tangent line. Okay, so as mentioned in class, the tangent line is the line that hits this point exactly once in this vicinity, okay, in this area. So we want this equation, like y equals mx plus b. It's some line, it's some equation, okay? So we have to think about how we're going to find this and what we need. Well, if you think back to algebra, you have a formula, y minus y1 equals m times x minus x1. And this formula allows you, if you put a point into this formula, which will have a point, which we already know from the calculator, I believe it was 221. 221, we have this point, we have an x1, and we have a y1. This is our x1, that's our y1, okay? But now we need a slope. Okay, so how are we going to find a slope? Well, if you remember, finding the derivative gets you the rate of change, which is the slope. So we're going to need the derivative. So I'm going to go ahead and erase this. I'm going to come back to it. And I'm going to find the derivative of f prime, which isn't too bad. It's 3 times 3, that's 9. Subtract 1 from the exponent, that's x squared. Minus 2 times -2 is -4. Subtract 1 from the exponent, you get x to the first. The derivative of a constant is 0. So we have found our derivative. But not only do I want my derivative, I want the slope when x equals 2. So what am I going to have to do? You're going to plug in 2 into the derivative function and solve. And that should give us our slope. So this is 9 times 4, that's 36, minus 8, that's 28. Okay, so we have our slope at 2, we have our coordinate at 2, So now all that's left is to get the equation using the point slope formula. So again, this is going to be our slope. So I'm going to put y minus y1, which, no, okay, if you're wondering how you get that, again, you would plug 2 in. Basically, you would do f of 2. And then 3 times 2 cubed minus 2 times 2 squared plus 5 equals 8 times 3, that's 24. That's minus 8 plus 5. That should give you your 21 there. Okay. So, however, I did that on the table in the calculator. That's how I knew it there. So that's just where it comes from. Now to finish this, m equals 28. X minus x1 is 2. And then you continue to solve. You're going to distribute. (28) times x is 28x, and 28 times negative 2 is negative 56. Add 21 to both sides. You'll end up getting negative 35. So the equation of this line that's going to go through this point is 28x minus 35. Now that's kind of tough to sketch. I'm going to make an attempt here. So that means you have a y-intercept at negative 35, and it also means that you're going to go from negative 35, you can go up 28 over 1. What's negative 35 plus 28? That'll be negative 7 over 1. And our line should kind of go in that general direction. Hey, what do you know? Worked out pretty good. Okay, so that's what we found. We found the equation of the tangent line that goes through 2, x equals 2, and well, yeah, that's what we did. and so we did that by plugging it into the derivative to find the slope, and then plugging the 2 into the original function to find the y coordinate, the y1, and then ultimately using the point slope formula. Okay, so lessons take away from this: if you take the derivative of the original function, you can find the slope at a point. You can find the slope at a point, just like we did here. And then furthermore, you can find the equation of the tangent line by using the point slope formula. Okay, so I'm going to go ahead and erase this part for some space. Then we're going to talk about cost and marginal cost. So the cost function is given. You'll notice there's a little typo on yours. The 2 is on the bottom. It should be up in the exponent. So correct that, please. So first question, find the marginal cost of the production level at X radios. So right now I won't say too much about marginal cost, other than to find marginal cost, you'll need to take the derivative of cost. So we're going to take the derivative of cost, and this will give us marginal cost. Okay. Actually, kind of the same thing. The word marginal, marginal revenue, take the derivative of revenue. Marginal profit, take the derivative of profit. Okay, so let's go ahead and do that. Oh, I might have moved it a little bit. Okay, so here, take the derivative of 1,000. It's constant, so that's 0. Derivative of 100x is 100. Minus the derivative of 0.5x squared. 2 times 0.5 is minus 1, and then x. So minus 1x. Okay, so that's the marginal cost, which can be written by 100 minus x, same thing. Now it says find the marginal cost at 80 radios. Okay, what do you think that means? Okay, that means we're going to do C prime of 80. So we're going to plug that in. We end up getting 20. Okay, and then that'll be our answer. Now again, kind of back to this, we found the rate of change at a point. Okay, so if we were to interpret this result, what we want to think about is what this means. So cost is in dollars, and so it's going to be a rate of change in dollars. Remember I told you rate of change is going to be your change of y over your change of x. In this case, our y is going to be change of cost, and our x is change of radios. Okay, so what this really means is that it's 20, so it's kind of like 20 over 1, right? So at a production level of rate of 80 radios, the rate of change of the cost is $20 per radio. $20 per one radio. Okay, when you're producing 80 radios. Okay, so that's kind of the interpretation of that, and maybe in a sentence, when production is at 80 radios, the marginal cost is 20, meaning cost is increasing at a rate of $20 per radio. Okay, and that'll do it. All right, thank you. Make sure you get the work done for the week, and I will see y'all next week. Take care.